Give me a second, I'm just sharing a link out before we get started. We'll give it a few minutes for people to join. Just share the link. So give it a few minutes and then we'll get started. We'll just wait for a few more people to join. And we'll start at 10 to, so we'll give it 3 minutes and if that, and then we'll start. Just check the other. There we go. All right, cool. So it's just before 10 to now. I'll start now. For those that are just tuning in, or those that tune in and watch the replay, everything will be shared on my blog after this live session. So don't worry about that. Bruno, thanks for tuning in. I'm good, thank you. How are you? And Babak, oh man, I have to sleep. I love this topic and I'll watch tomorrow. Please create the same for any connect as well. No worries, I'll see what I can do. Yeah, you can watch the replay anyway. The replay will be available after this live stream anyway. So we'll kick things off. For those that are tuning in, thanks for tuning in. I hope you find this session useful today. This is episode 8, so we're 2 more off after this session of finishing the first series of the knowledge transfer sessions. For those that follow me on Twitter, I put a poll up. Please do take a look at that and let me know if you found these interesting, and then I can continue to produce content that you guys like based on what I know, because that's what the knowledge transfer is all about, right? So yeah, today we're going to look at configuring site-to-site VPNs on the ASA firewalls. We're not going to deep dive into every little specific thing because there is quite a lot to cover. However, we're going to focus mainly on the configurations on the ASA. So I've put together, as I always do, a presentation that covers what we're going to be talking about today and configuring. So we'll start with a quick overview of IPSec L2L VPN. So the L2L actually stands for LAN to LAN, and as you can see there, it's also known as site-to-site VPNs or virtual private networks. The purpose of VPNs is to allow secure connectivity between private networks over untrusted networks such as the internet. So for instance, if you've got a main site and you have a remote branch site, a smaller site, and you want to be able to establish secure communications over the public network, you could establish a site-to-site VPN to do this. So this is the perfect solution to do this. Obviously there is other VPNs, but we won't be talking about them today. Just before I carry on, any questions that you guys have or post, I will take a short break and I plan on answering them or catching up with you guys. But again, thanks for those that are tuned in. So there's 2 phases to IPSec site-to-site VPN, and that is phase 1, which covers the IKE version 1 or version 2. We'll be focusing on version 1 today. And then there's phase 2, which is IPSec. So IKE is Internet Key Exchange, and then you've got IPSec, which is IP security. So IKE is used for key management and the creation of the IPSec associations. So it's used for that to establish so that phase 2 can occur. And IPSec provides then the security for the data traffic. IPSec provides the following. So it provides the confidentiality, integrity, authentication, and also provides anti-replay protection. So in short, it provides CIA. So that for those that are actually covering maybe the CCNA security, you should have come across CIA by now. I think it's one of the first chapters, or at least it was when I did it. Confidentiality is the encryption of the data. Integrity ensures that the data isn't modified in transit. And then authentication verifies the identity of the sending IPSec device. Anti-replay protection, for those that haven't heard of that, stops an attacker from replaying the traffic using sequence numbers. So there's an actual window of sequence numbers, and yeah, it basically stops anyone trying to snoop on traffic from actually replaying that same traffic. Again, this is a quick overview of the IPSec fundamentals. I have put a little reference list together that I do suggest that you look through. This presentation will be available on my website cybercbk.co.uk after this session, so you can go through this again. So IPSec makes use of one of two protocols. So we've got something called authentication header, which uses protocol 51, and it's RFC 4302. And this is the origin authentication and data integrity, but it doesn't cover confidentiality. So if we go back to the top here, it's not going to cover the encryption. So it'll cover integrity, and it'll cover the authentication. And then we've got encapsulating security payload, which is ESP, protocol 50, and RFC 4303. And this does cover confidentiality, integrity, and you've got the option to have authentication as well. So AH and ESP support two modes. So they support tunnel mode. So ESP and AH are applied to interesting traffic that's tunneled. And I've put in brackets there, gateway to gateway security. And then we've got transport mode, which is allows for ESP and authentication header to provide protection end to end. So this is client to client, but could be a network device also. And that little bit there at the end I've took from actually one of my colleagues in my team. He's responsible for writing a very good book that's also in the references, and yeah, he's pretty much the go-to guy for VPNs, so I've been reading quite a lot of his stuff as well. So these are the reference points that I'm talking about. So I've put an overview, I did a few years ago, the CIA triad overview on my website. Again, these links will be shared after this presentation. And I've also put the links to, for those that want to read the joys of reading RFCs. You can read up about the ESP and authentication header a little bit more. And my colleague who's in my team, Graham, very good guy, especially with VPNs as well. He's actually wrote a book, and it's called IV2 IPSec VPNs, and it's by Graham and another guy called Amjad. I really do suggest that for anybody that's going down the security route, you purchase this book, because it's a really good book and it covers you know, what you need to know about IPSec and VPNs. As you can see, it covers more to do with the IKE v2. We're covering IKE v1 today. There's a few amendments, but yeah, I really do suggest that you check out that book if you get a chance. So today's topology is something like this. So just to kind of illustrate a little bit better, we're going to have, let's just say for instance, VPC4 is our main site, and then we've got VPC5, which is, let's say, our remote site. And we have internet going out to the public internet here for both ASAs. So that'll be the outside interface. And what we're going to do is we're going to establish an IPSec tunnel from ASA 1 to ASA 2. And then we're going to pass traffic and make sure it all works. Hopefully it does all work, or it's going to be a longer session. So I've also put steps and configurations here, which I want to quickly go over. And for those that are new to VPNs, I put a little tip which might help you. It helped me when I first started learning about VPNs. And that is, we need to start off by configuring phase 1, which is the Internet Key Exchange. So we create the IPSec policy. And I put in brackets there that the lowest policy has priorities, because you can create more than one policy. So the lowest policy, so policy 1, let's say, over policy 2, will be preferred. And I've put there, basically within the IPSec configuration, you need to configure the parameters. So I've put a tip, and what you can see there is haggle. So if you remember haggle, you'll be able to remember the way you configure IPsec v1. And essentially, you configure your hashing, so H, and then you configure your authentication, A. Then you configure your deferment group, and then your lifetime and encryption. So if you remember haggle, then you should be able to configure IPsec v1. I appreciate those that are new to the security domain, especially Cisco. You might find this a little bit daunting. I mean, I do create these videos for the Lab Everyday community, and what I want to say is that basically when you do your CCNA security, you're not at all required really to use the CLI to navigate around the ASA firewall. But in essence, in real life, if you can grasp the skills and knowledge required on the CLI of an ASA, it'll put you in a much better place when it comes to actually doing things for customers or in your job. So the reason I wanted to do this as well is to try and steer people away from ASDM and get used to using the command line, because, you know, I mean, when I first started using the ASA, it was a little bit daunting. You know, it's slightly different to iOS configurations, and you know, there's a lot to learn. And you know, I thought, okay, I'm going to be stuck on the ASDM, you know, for quite a while. And basically, the more you work on the CLI, the less you're going to rely on ASDM, and it's going to make you a better engineer in my opinion. So this is why I'm doing it via the CLI and not ASDM. So I hope you appreciate that. So once we've configured the parameters for IPSec, we're going to configure the site-to-site tunnel parameters, and then we're going to configure the interface, or we're going to enable IPSec on the interface, which is going to be the outside interface connecting to the peer. Phase 2, we then go on to, so I've put configuring objects for interesting traffic, and the reason I've put this under phase 2 is because you pretty much apply it to crypto maps anyway. So what we're going to do is we're going to create object networks for the both sites to specify what traffic should be encrypted, and then we're going to create crypto ACLs that will then be defined by the crypto map. Then we're going to configure the IPSec transform sets along with crypto maps, and we're going to need to consider NAT for our topology today actually, so that's going to be interesting. And interface security levels we don't need to really worry about, but sometimes you may need to worry about that if you've got same security levels on inside and outside interfaces. With this as well today, I've actually put an example configuration in the presentation, for those that are interested. Again, this will be available on my website after the live stream, so you can head over there and go back to this presentation or take a look in further detail. So without further ado, we're going to jump over to the lab and we're going to start configuring the site-to-site VPNs on the firewalls, the ASA firewalls. But before I do that, I'm just going to see if we've got any questions and give a few people a shout out. Okay, hi Bruno, thanks for tuning in. Firewall, so I can use it. iOS ISO firewall. I think you mean iOS firewall if you're looking at a router, or ASA firewall. You need to get the images, maybe from GNS3, that might help. Geek 4001, thanks for tuning in. Yes, the recording will be available after this session. It'll be on YouTube, and it'll also be on my website. So look out for that if you're interested. Shout out to all the Lab Everyday community. Shout out to Dewan, Antonio, all those guys there doing the thing. If you've not already subscribed to Dewan, which I'm sure you have already, head over to his channel and subscribe. We started producing content that helps the community in looking for jobs and basically inspiration and moving forward in life with the IT careers. So for those that haven't checked that out, head over there. Hopefully you find that stuff useful as well. Alright, cool. So let's head over to the lab and hopefully you guys can see that I've made it as big as I can. If you can't, just give me a shout, but I'm sure you can. Alright, cool. So this lab is totally clean, empty, no configurations whatsoever. So we're going to start off with a fresh topology, and we're going to configure everything from IP addresses so you can see how it's done from the start. So what we'll do is we'll start off with ASA v1, and I'm just going to change the host name, and we'll call it ASA v1 just so we don't get muddled up with the other one. And we're going to configure the inside interface of the ASA, which is gig02. So we'll do interface gig02, give it an IP address, and it's going to be 192.168.10.1, and it's a /24 network. And we'll do name if inside, we'll give that a name of inside, and you can see it's assigned a security level there of 100. For those that aren't too familiar with that, go back a few videos on my YouTube channel where I explain what a DMZ is, and we cover that in there, so you can take a look there. And then we'll issue a no shutdown. So let's give that an IP address, interface name, and security level. And while we're here on the same ASA, we might as well configure the outside interface. So interface gig00, IP address 209.168.100.1, and it's a slash. It's supposed to be a /30, so it's 255.255.252. No shut. Name if, we're going to give it outside, and it'll give it a security level of 0. So quickly while I'm on here, I'm just going to change that there just so you don't get confused. So it's a /30 on both sides. Gives it 2 available IP addresses. There we go, cool. Okay, so that's ASA v1 interface is configured for now. What we'll do is we'll jump over to VPC4, and we'll just give that an IP address. 192.168.10.1. 10 we'll give it. /24, default gateway is 192.168.10.1. And if I do a show, we can see now that that's got the configuration applied. Can we do an ARP? ARP table's empty. Or if I try and ping 192.168.10.1, there we go. So we can ping the inside interface of the ASA. And if we do an ARP now, we can see the MAC address, etc. So that's the main site configured if you like. What we'll do now is we'll jump over to VPC5 and we'll do that one. IP 192.168.20.20 we'll give this one. /24. Gateway will be 20.1. And we've not done that yet, so we'll now configure ASA2. We'll just change the host name again, ASAV2, interface gig02, IP address 192.168.20.1 we said, /24, give it an interface name of inside, no shutdown. We'll jump over to interface gig00, which is the outside interface of ASAV2. IP address 209.168.200.1 and it's a /30, so it's 252. We'll give it an interface name of outside and we'll do a no shut on that. So we'll just head back over to VPC5 now and we'll see if we can ping the inside interface 20.1 and yes we can. Okay, cool. So we'll just do an ARP. Yep, so we're good. So that's ASA 1 and 2 and both VPC IP addresses configured for now. So we'll head over to what would be, let's just say, the ISP router, which is in the middle of the topology. And we're going to configure static routes for both networks. So we'll start by configuring the interface IP addresses first. So interface gig00, which connects to ASAV1. IP address 209.168.100.2. 252. Now shut that interface. Interface gig01. IP address 209.168.200.2. I'll shut the interface on that one as well. So we've got both IP addresses set there. Do show IP route. So we can see that we've got both networks for the outside interfaces, but we have no routes. So what we're going to do is first on this, what we call, let's just change the host name. In fact, host name, we'll call it ISP router. What we're going to do is we're going to point routes. We could use dynamic routing, but we're not going to do that because let's imagine it's just an ISP router. So we're going to point static routes to each network in our case. So we'll do IP route, anything destined for 192.168.10.0. It's going to go via 209.168.100.1. And the same for ASAV2 side. Anything destined for 192.168.20.0 is going to go via 209.168.200.1, which is the outside interface of ASAV2. So just do a show IP route, and we can see now that at the top we have the static routes in there for both networks. So what we're going to do with, let's jump back onto this, and we'll do a show route on the ASA. We can't see anything for 192.168.20.0, so we need to point, basically what we should do is just point a default route out of the outside interface. So we'll do route 00, nope, that's wrong. Route outside 000. That's the difference when you're working with iOS and the ASA. The commands are slightly different. Route outside default, and we're going to do it via gateway 209.168.100.2 is the next stop. Show route. So we've got a default route there now. The outside interface, so everything's just going to get routed outside there. We would need NAT, but because we're going to set up a VPN and exclude NAT for the VPN, we'll see how that works soon. So we'll jump over to ASA v2, and again we need a route going out, a default route, so we'll do route outside default route, and we're going to send it via 209.168.200.2, and there's our default route now. So we are good. Yeah, via 2. Alright, cool. So if we try and ping 209.168.200.2, we can ping that interface of the router 200.1. We can ping the outside interface of the ASA, but we won't be able to ping inside because it's a firewall. So what we're going to do now is we've arrived at the VPN configuration stage now, which is good, which is what I'm sure you've all been waiting for. So we'll just head back over to our lovely little presentation, and these are the steps here, which we discussed earlier, and here's how them steps translate into steps like this, pretty much. So we're going to start off with phase 1 configurations. So let's head back over to, let me just get that screen back up, there we go. Let's head back over to our topology. And what we're going to do is we're going to start by creating the policy for IPSec v1. So we'll do it on ASA v1 first. So we'll do crypto, and as I said, we're going to use IPSec v1. We have the option to use IPSec v2, but for this lab today we're going to use IPSec v1. And we're going to do policy. So if you just do question mark, you can see policy there. And we're going to start with policy 1. So as I said earlier on in the video, the highest is number 1. So the lower your policy number, the higher priority is. So we'll just do policy 1. We'll start that. Create, and as you can see now, we've been entered into the IPSec v1 policy. So if you do a question mark, you can see that we have the haggle stuff there. Pretty much everything that we spoke about, it's in there. So if you remember the haggle, you should be able to configure this. So as I say, we start with H for hash, and we'll do MD5. No, we won't. We're going to do SHA. Yeah, we'll do SHA. Yeah, let's do SHA. A for authentication. So you can see that we could use RSA or we can use pre-shared keys. So we're going to use pre-shared keys. So we'll do pre-share. Group. We're going to use defilement group. Let's use group 2. And then we'll do L for lifetime. Oops. So we'll do 86400, which is 84600, which is 1 day, if I'm correct. Yep. And we'll do, last but not least, encryption, which we are going to use. Let's use the strongest. So let's use AES256. So we use AES256. So that's pretty much the Haggle complete there. So as I say, you remember Haggle, you should remember how to configure all that. And what we're going to do is we're going to configure we'll exit out of that, and now we're going to configure a tunnel group. So tunnel group, question mark, so we enter a name for the tunnel group. In our case, what I'm going to do is I'm going to add the IP address of the peer outside interface, so 209.168.200.1. You could name it whatever you wanted. And our type, so if I just do a question mark again, the only option we have is type. So type, we are configuring not a web VPN, remote access VPN. We're actually configuring the IPSec LAN to LAN, or L2L, site to site. So we'll do IPSec L2L. And then we'll do tunnel group again, and we need to specify the same name that we did, because this is related to the same tunnel group. So 200.1 is the name that I give, and we're going to specify the IPSec attributes. So we press enter and we go into the IPSec tunnel, and we're going to specify that we should use IPv1. So we can use again IPv1 or IPv2. We're going to use IPv1, and we're going to use, let me just question mark that there. So we can use pre-shared keys, which is what we're going to use. So we'll do pre-share keys, and then we should be able to enter a password here. So for the purpose of this lab, obviously not a secure password, but we're going to use Cisco all underscore, and then we're going to press enter on that. Exit out of that because we're done with the tunnel group now, and that's IKE v1 phase 1 configurations complete. So if we head back over to our presentation, so yeah, we've done. No, we aren't done. We need to enable the. We need to do the outside interface. So this enables IKE v1 on the outside interface. So we'll do that. So we did the Haggle stuff here with the policy that we created, and then we did the tunnel group. And again, here I've also put in an example the IP address of the peer. And then we specified that IPv1 is going to use pre-share keys, and we've give it again a password of Cisco. So we'll go back over to our lab, and what we're going to do now is we are going to enable it on the outside interface, as I said. So we'll do crypto IKE v1 enable, and we can see if you do a question mark, then it'll bring up the interfaces that you've configured. So we're going to enable it on the outside. Oops, see. Let's just do that again. Crypto IKE v1 enable outside. There we go. So we'll enable it on the outside interface. So yeah, that's IKE v1 perimeters done. So now we're going to move over to phase 2, what you can see there. So we're going to configure the objects for interesting traffic, and we're going to configure the crypto ACL that will be defined by the crypto map. Then we're going to configure IPSec transform sets, configure the crypto maps, and then we're going to consider NAT, because what we don't want to do is we don't want to NAT our internal private IP addresses going across the tunnel. Alright, cool. So, and that's what, again, that's what it translates to there under phase 2 IPSec. So we'll head back over to the topology, and what we're going to do is we're going to create object networks for pretty much for both of this network down here and also this network here. So we'll do object network, and we'll call this, let's call this site 1. Subnet is 192.168.10.0. So that's object 1 created for site 1. We'll do the same for site 2. Subnet 192.168.20.0, and that's site 2 subnet created as well. So if I just do show run object, we can see that we've created 2 objects here now, which will you'll see where these are used in a minute. Alright, cool. So now that that's done, we're going to create what we call a crypto ACL, and this is going to cover the interesting traffic that we want to be encrypted. So we'll do access list, and we'll call this, let's just call it crypto, extended permit, and we're going to permit IP from object site 1 that we created going to object have I done that? Let me just go back there. Yeah, so object site 1 going to object site 2, show run access list. So that's the access list we've created here. So our access list is called crypto, and we are permitting IP traffic from site 1 subnet, so from 192.168.10.0 going to site 2, which is 192.168.20.0. so that's the interesting traffic. Now we're going to go on to specifying the transform sets. So we'll do crypto IPSec, and we need to specify IPv1. So set the IPv1 settings here because we're using IPv1. Transform, so again transform set if you question mark, and then we get to give it a name, so we can call this anything we want. So let's call it let's just stick with what I started learning by, so my set, and you'll see that specified in quite a few places. And then we can specify the algorithms that we should be using here. So let's do encapsulate and security payload. So as I spoke about that briefly at the start of the presentation, we're going to use that because it gives us the encryption as well. And we're going to use AES 256, and then we'll use ESP. Use ESCP, sham, we'll use hash message authentication. Alright, cool. So that's the transform sets complete. These must be identical on both ends, and as I say, include the keyword of IPv1. They're basically just a set of protocols and algorithms that secure the data. So if we now do crypto maps, so we create crypto maps, so we need to give it a name. So let's call that access list crypto, so let's call our crypto map keep it simple. So crypto map, and we get to give it a sequence to insert into the maps if you've got other crypto maps configured. We're just we'll stick with 10, so we'll give it a crypto map of 10. And then we're going to match address. And what we need to do here is, if I've shown you the question mark there again, we need to match it against the access list name. So we called our access list crypto. So crypto, and we'll enter on that. Then we need to then specify the peer IP address for the crypto map. So we'll do crypto map is the name, 10, and we're going to set peer. So the peer is going to be 209.168.200.1. Yep, 200.1. So that's the peer we've specified. So that's the outside interface of the ASA v2. So once we've set the peer, we now need to include the transform sets into the crypto map, which we created earlier, a few commands ago. So we'll do crypto map 10 oops, 10 set, and what we're going to do is we're going to set the IPv1 policy. So we're going to bind this. So IPv1 transform set, and if you remember what we called our transform set, I think it was my set here. So we need to specify that here. So if I do question mark, we need to add the transform set that we created. So it's called my set, wasn't it? Let me just double check. Yep, my set. So this basically configures the crypto map to use the IPv1 along with the algorithms that we specified in the transform set. So we press enter on that, and we're still not finished with the crypto maps because we need to set the security association lifetime. So we'll do crypto map, again, that's the name that I specified, 10, set security association lifetime, and it's in seconds, or you can do in kilobits, so we're going to do seconds. So 84600 is 1 day, isn't it? I believe. Yeah, I believe that is. Correct me if I'm wrong. And then last but not least, we need to apply the crypto map as we did with, so we enabled IPv1 on the outside interface. We now need to apply the crypto map on the outside interface. So what we do is we do crypto map, I'm doing in capitals here, crypto map, the name of the crypto map, interface, and it's outside. So you could do question mark, and again it'll bring up the interfaces that you got configured. So we'll do outside. So now that's applied the crypto map to the outside interface. Alright, cool. So if we do, in fact, what we need, so that's basically that's pretty much the configuration that's required now. We do need to exclude, in fact, so we need to include a NAT statement that's going to exclude the 192.168.10.0 being NATed as it traverses the firewall. So what we do is we do a static NAT, which basically NATs it to itself. So it's essentially a no NAT statement. So we'll do that now, and then we'll head over to ASA v2. We'll do the same configurations again, but for the other side, and then we'll see if we can establish a VPN, and we'll do a few short commands. So let's do the NAT statement. So we'll do NAT, and again that's different on the ASA for those that are not familiar with it. So we're NATing inside to outside, interface wise, and we're going to do source static, and we're going to specify our object group. So it's going to be site1. So this is for the rail source, so that is the rail source. And then if you do question mark, now after you've done that, now you specify the map source. We're going to do site 1 again because we're mapping it to itself, so essentially it's a no-nap. And then we're going to do the same with the destination. The destination static, and that's going to be site 2. So this is the mapped address first instead, so it's the other way around. So map destination is going to be the rail address, site 2, and site 2 again for the rail address. There we go. And we're going to do disable proxy app on the egress interface. So we'll do no proxy app. And if you do question mark again, so we're going to permit root lookup for the rule. So what it's going to do is going to do a root lookup for the for this NAT rule. So we'll do root lookup, and that's it. So this will exempt show run NAT. That's our NAT rule here. So this is going to exempt the inside network 192.168.10.0 from NAT when it's traversing, or when the destination is site 2 192.168.20.0. So that's the configuration done on the first firewall. So we'll quickly head over to the second firewall, and we'll quickly run through the configurations again. So I won't talk through them like I did the first time. I'll just kind of put them in because you've seen there, but feel free to follow along. So I'll just do crypto IP1 policy on, and we're going to do ashin SHA authentication pre-shared group 2 lifetime. Let me just check that. Show let me do show run crypto like v1 so 84600 and encryption AS256. Let's copy that over. There we go. Alright, cool. Exit out of that. We'll enable it on the outside interface. Crypto IKV1 enable outside tunnel group. We'll give it the what did I give the other one? I give it the P as IP, I think, didn't I? 200.1, yeah I did. So we'll give it the, likewise we'll do the same. So 209.168.100.1, and it's type IPSec LAN to LAN. Tunnel group again, IPSec attributes, IV1 pre-shared key, and it's Cisco all lowercase. Exit out of that. We'll head over to the phase 2 configuration. So object network site 1 subnet 192.168.10.0/24. We'll do site 2 subnet 20.0. For those that are just tuning in, I'm doing this site quick. You could just, when the recording's finished, you'll be able to go back and see the slower side. ASA v1 has a walk through it. So that's that one done as well. So we'll do access list, crypto we called it, extended permit IP from this side is going to be from site 2 first. So site2 to object site1. Show run access list. So make sure it's in there. Permit IP from object site2 to site1. That's right. So now we're going to do the transform sets. Crypto IPSec v1 transform set. We'll call it my set again. We're going to use, let me just double check the settings. Show run crypto IPSec. Alright, cool. We're just going to use the same settings here. So I'll just copy that over. Cool. So that's that configuration done for the transform sets. So we'll do the crypto maps now. Again, that was just make it easy and quicker. Show run crypto map. So we'll use the same crypto map. Match address crypto. We're going to change the peer address because that's going to be different. So let's just copy that over. The peer is actually 100.1. So that's right now. And then we're going to use the same transform set and the same, yep, so all that's going to be the same there. So we'll copy that over, make it a little bit quicker instead of typing it all out. So that's done, and then we'll do the same for the NAT. Show run NAT. So we need to just flip the objects around for the other side. So we'll do this, and then we're still not inside to outside, but it's going to be from site 2 going to site 1. Alright, cool. Show run that. Just make sure I've done that right. And did I enable it on the outside map? Yep, I did. Okay, cool. So with that done now, this should essentially be all we need to configure for the site-to-site VPN. So there's a few show commands that we could use to have a look at the IPSec v1, the ASA KMP, and the IPSec. So we'll take a look at them now. So we'll head back over to ASA1 and we'll just do show crypto ASA KMP SA. So there's no security associations yet. Show crypto IPSec SA. There's no, obviously if there's no IPv1 associations, there ain't going to be any IPSec security associations. Now the reason being is because there's no traffic passing. For the tunnel doesn't just establish. For the tunnel to establish, you need to send traffic, and the traffic needs to hit the crypto maps for a tunnel to form. So we're going to do that now. So we're going to try ping from our PC. Hopefully VPC works. I've had a few problems with these in the past, but we'll see. So we're going to try ping site 2, which is using ping 192.168.20.20, I believe that PC is using. First couple should time out. There we go. So now we can ping across the site. So if we have a look at ASA v1, we do show crypto IC KMP SA. We can see now that our tunnel is active, so we've got one active security association under IPSec v1. We can see that our peer is 209.168.200.1, which is the outside interface of ASA v2. We can see that the type is L2L, a LAN to LAN or site-to-site VPN, and we can see that the role that this ASA has played, it's been the initiator. I won't start talking about states, but that's main mode active, and obviously we haven't configured IPv2, so I ain't got no associations there. So we'll look at the show IPSec SA. So this is where you get all the nice details. So we just sent, let's go back to VPC4. So we just sent, or at least 4 packets. So the first packet timed out because it was still establishing the VPN when it's hit the access list. So 4 packets have actually gone through the VPN to VPC5, which is good. So we can see here that we've got 4 encaps, which means 4 encapsulations over the tunnel. It's digest 4 packets, and it's also decrypted 4 packets, or decaps, and that's obviously the replies coming back, which is good. So what else can we see on the show IPSec SA? So we can see local crypto endpoint. We can see is 209.168.100.1. So that's our side, and then we can see there's a lot of security primary index here. I'm not going to start talking about all that. You've got ESP, encapsulated security payload. So you can see that the key lifetimes down here for both. You can see anti-replay detection is there. We can see that the transform sets that we've used are here configured, and we can see that we're using tunnel, IPv1, LAN to LAN. Alright, cool. So let's take a look at the show access list. So you can see that we've got 5 hits on the access list. Obviously, going back to the VPC, the first one timed out, but it's still hitting the access list. And then we can obviously see, you know, obviously the other ones have gone through. So we've got a hit count of 5 there. What if we do a show NAT? So we can see translated, untranslated hits here. So if we have a look at show xlate table, we can see that we're NATing from inside 10.0 to outside 10.0. So this is basically a no NAT, as you can see here. We're NATing to itself, and again we're NATing to itself there. What else can we do? Show crypto IPSec. We'll do stats. This gives you some good stuff. So you can see that we've got 1 active tunnel. Previous tunnel, obviously, it's the same one. And we can see the bytes, we can see the packets, we can see if there's been any drop packets, we can see the authentications and failures if there has been any. And that's for inbound, and then we've got obviously outbound as well. And then we can do show ICKMP stats. So again, you can see loads of IPv1 statistics here. Lots of information here that you can drill down into. How about if we so essentially that's the IPSec VPN established. So that's pretty much completes the lab. So just before we do, what I'll do is I'll do a quick debug. I'll take down the interface, re-establish it, and we'll see what happens in the background before I've been seeing if anyone's got any questions and finishing off. But so essentially this is a configuration that we have used to establish a site-to-site VPN. The steps are there without the configurations. Again, like I said, we'll include this on my website after. And that's essentially it. So I've got the reference points for you guys and a quick overview of IPSec site-to-site VPNs. There's a lot more detail that we could go into about these IPSec VPNs and VPNs just in general, but that's not the purpose of this video. The purpose is to configure IPSec VPNs, site-to-site IPSec VPNs, and show you how it's done on the ASAs. I hope it's been useful for those that have tuned in so far. What I'm going to do is I'm just going to shut down the interface, but before we do that, in fact, let's have a look at, we didn't look at ASA 2, so it should be the same. Show crypto ICAM SA. So we can see that the role on this side is a responder, whereas if we do show crypto ICAM SA, we can see that the role on ASA v1 was the initiator. Now that's because the packets was coming from Site 1 or ASA v1's internal interface, so it's initiated that tunnel, and then ASA 2 as being the responder. So we pretty much get the same output, as you can see, for the other side as well. So just to finish off, we'll shut down the outside interface, we'll turn on debugs, and we'll see what happens. Debug crypto ICAM, how is it? VIP. Yeah, let's debug IC v1, and we'll debug crypto IPSec. Alright, cool. And we'll go on to interface gig 00. Shut down that interface, and we can see there that we've got syslog message already saying that the session's been torn down, reasons unknown. So if I do show crypto ICAM PSA, we can see that there's no v1 security association now, which means there's not going to be any IPSec SA. There we go. So now let's do no shutdown on the outside interface. And again, as I said, you need to initiate traffic in order for this to establish the VPN. So again, now the interface is not shut down, we can still see that there's no security association. So what we'll do is we'll generate flows from VPC4. And now let's see what happens. So we can see here that we have a route lookup for local address to remote address. The PO matched crypto map sequence 10, which is what we created. We got a rule lookup, PO matched crypto map sequence 10, proxy match. Yeah, that's fine. And that's it. So I thought I'd get more output than that, but I actually haven't. But yeah, that's pretty much. So if we do show crypto ICAM SA, we can see now that the tunnel's active again, and the initiator's being the same side. So I'll tell you what we'll do, just to finish off, we'll shut down this interface again on ASA v1, and what we'll do is we'll jump onto ASA v2, show crypto ICAM SA. That's still up. Let me try ping from 192.168.10.10. Timeout, and there we go. So let's do it now. So we can see now that ASA v2 is now the initiator, and ASA v1. Still got debugs on there as well, and ASA v1 is the responder this time round. Cool. So that's pretty much it from a knowledge transfer session on configuring site-to-site VPNs on the ASA firewalls. I'll just see if there's any questions before I finish off. Alright, cool. Good morning, Christopher. Don't worry, you can always go back and tune in and watch the replay after this session. Bruno, how can I get the images? Honestly, the best answer I could give you is just to search around on the internet. I mean, I can't send and won't send images because it's not something I'm allowed to do. But yeah, the best answer I can give you is search around or ask others that might be able to share images with you. So I hope that helps. Tech tips, thanks for tuning in. Congratulations on passing your CCNP route. Cool, and then the session with Dewan was awesome. Thank you. We enjoy doing it. We enjoy those sessions, me, Dewan, Antonio. We hope you guys enjoy it and take stuff away from that. Yes, Dewan, I see you. Thanks for tuning in, man. I hope you've enjoyed the session as well. Congrats in the pass. Adriano, thanks for tuning in. Is the material covered in the CCNA security? It is covered in the CCNA security, but as I mentioned, I'm not sure when you tuned in, but as I mentioned, you're not required to configure VPNs in the CCNA security using, well, at all, I don't think, but if you are, you're not required to use the CLI. You'll only be required to use ASDM. But as I said earlier on in the video, the reason I'm delivering this knowledge transfer session to the Lab Everyday community using the CLI is because it's better to be able to use the CLI than it is to use ASDM, because when you get out there in the big bad world, or if you're not already in there already, you're going to find that you know, you need to be able to do it on the CLI rather than trying to get access to ASDM. And not only that, customer sites or equipment that you're configuring might not have ASDM enabled. You know, it might just be CLI access, so you need to be able to configure on the CLI. So it is a must. I could have delivered this session today using ASDM. It would have taken about 10 minutes, if that, using the VPN wizard, but like I say, I want to try and give you guys the best of what I know, and hopefully prepare you for, you know, going out into the industry if you're not already in there. So, you know, I hope these configurations have been useful. I hope this session's been useful, and as I say, I will be sharing the presentation on my website after, so you can go away and take the presentation. What I will do as well is I'll copy the output of my configurations, and I'll share those as well on my website under the same post, so that'll be useful for you guys. And another thing, I mean, as I said earlier, I've got 2 more sessions of the first series of these knowledge transfers, which, you know, I'm sure you've all enjoyed. I will be doing some more by the looks of, you know, people wanting me to carry on doing that. I also have some other exciting news that I want to share with you guys, and that is that I plan on delivering another series of sessions which is purely troubleshooting. So based on the labs that I do, I'm going to break those labs, and I'm going to provide partial configuration output and leave you guys to try and solve the issues that are presented when I share. So hopefully that's another way for you guys to get motivated and increase your troubleshooting skills for those that are interested in doing that. So I hope you guys will find that useful as well. But that'll be coming soon. Just look out for that. So yeah, I hope that answers the question. Yeah, exactly. Dewan knows, you know, CLI is a must. And yeah, I guess, yeah, from when I did the CCNA security, I think it was all ASDM. You weren't really required to jump on the CLI. So it's a little bit daunting because, you know, you get your CCNA security and you still haven't really had exposure to the CLI of an ASA, and it's quite scary, especially if you're in the industry working. So you need to really be able to deliver on the CLI, and that's why I'm trying to give you guys this session today. So cool, I'm going to end this session here. I hope you've all found it useful. Feel free to keep commenting and sharing, and until next time.